far so good. I say, imagine that Q is called Q, and I say NQ, say 7. So you should put a 7 here, right? Now front should be 0, and side should be 1, right? Then let's say I do NQ 8, so I will put 8 here, right? And then I say NQ, say 9. 9 goes here, right? Correct? So far so good, right?
Yeah.
Do I have to update the front? No. When you're in Q, you don't have to update the front unless you're in Q in the first time, right? But what you have to do every time you're in Q is update the size. Should be 3 now. There have been 3 in Qs, right? Now, the problem comes when we start dequeuing and we start making the Q look weird. If I say dequeue, this means I will remove an element, right? And I always remove the one at the front because that's the one that should be served first. So if I do that, front is no longer here. Front has to be here now, right? Got it? So front becomes 1, correct?
Yeah, correct.
If you want, I can delete this one. You're not going to really delete it, but let's say it's deleted, okay? The idea is that if I want to do Q, that and Q, let's say 10, is that you're going to try to put next to it, but next to it there is nothing. There is no spot 3, right? So that element has to, but size is 2, right? Because you have removed 1, right? So size tells you that it's smaller than capacity. Therefore, if the size is smaller than the capacity, that means that you still have available spots to insert the element. So this 10 should be inserted. Now it cannot be inserted to the right of 9 because it's already full here. So I have to insert it here. Correct? So 10 would have to go here. Right? How do we determine the position where something has to be inserted? At the beginning it looks pretty simple, right? We have a Q like this, right? Let's say I have an element 9 here. This is front, right? And size is 1, front is 0, right? 0, 1, 0, right? We said that it looks to be simple. If the array is called A, looks like I have to insert the thing at position front plus size. Front plus size 1, okay, here's where I have to insert the value, right? Correct? And this seems to work because after I insert 10, say I want to insert 11, size is 2 now, right? Say I want to insert 11 here, front 0 plus 2, 2, so I have to insert it here, right? Seems to be working. But when I have something like this, front is 1, right? Size is 2. 1 plus 2 is 3. That means that I actually insert in position 3. Do I have position 3?
No.
So that formula of just doing this insertion at position front plus size is not going to work. Right? Why? Because front plus size now is bigger than the valid indexes. So you can detect that by doing something like, okay, if front plus size is equal to capacity, then it means that it cannot be inserted in that position. It has to go round. Right? So one way of doing it, we said, is if front plus size is greater or equal to capacity, then let's make the position to insert front plus size minus capacity. 0 plus 2, 2 minus capacity, sorry, front was 1, 1 plus 2 is 3, minus capacity 3, right? Capacity is 3, right? Will be 0, will give me this index. Got me? But some people say, no, that looks kind of ugly with the formula. So if I do this, front plus size, and I get more capacity here, and I say insert at this position the element, and this works. Because if the front is 1, right, and size is 2 would be 3, right? 3 mod 3, the modulus of dividing 3 by 3 is 0, that means it's 0, right? So I'm getting the number where I have to insert. 0. I have to put in position 0. Got it? And here it works also, because if I am here, the next position is here, right? 0 plus 1, 1. 1 mod 3, 1. Got it? If you divide 1 by 3, quotient 0 remains himself, because it's smaller. similar problem. With DQ, well, if it's empty, you cannot DQ. You always get the element at the position front. That's what you want to return. So n that you have to return will be the element at the position front. That's clear. The problem is determining if I have removed an element, who should be my front now? Correct? You say the next guy. So you would say front plus 1 mod capacity, so that if the next guy is going outside, it can go at the beginning. Something that you can consider here is to put what happens if the list becomes empty. You detect that the list can carry empty. Well, you can detect the list can carry empty like this, right? If size is 0 now, right? If it just became 0, front should be equal to -1. That's something we had yesterday. Because if I remove the last element, this pretty much, I remove the last element, the front should be -1 again, right? That's something I forgot to put last class. Not such a big deal. Is that clear? Yes? So send this over again, okay, Greg?
Oh, okay, send back Q.
Q, yeah, the Q forward. But even if you don't send it, they should be able to figure out. That's very simple. Now, I didn't play much with Qs, I think. So we're playing here with Qs, right? First, remember. I will create a main play with the Qs and you will see how it works. If I want to print all Qs, I can do something similar to these tags, right? I can start removing and printing, right? Correct? Same idea, right? I can even copy the code from the stack, right? It was very simple, right? While Q all simple, but it's not empty. Well, it's not empty. And equal Q, just the Q. Q element and bring down. Right? Correct? And if you want, you can put your system out in line, put a changes line and put them all next to it. If you want to put one next to each other, do a system out print and put space here, for example, right? So if I just want to test in Qs, I want to test Qs, you can clear Q. Start playing with it, right? So I can say Q, my Q, new Q, right? And then the capacity for this Q say 10. And then I can Q, I can say my Q, that, thank you. Let's say my Q, and then if I want to print, I can say my Q, what am I going to print? Can you guess? Okay. How's it going to look like? All right?
Before 8,
You say
4 and 9.
You say 4 and 9? Before?
It'd be 8 and 9.
Oh, yeah, that's right. Yeah,
Sorry?
8 and 9.
You say it's good. You get a point, say.
I'm going to register.
Very, very, very nice, right? Because the 4 was inserted first, it's 5 for them. That's the first one you should be doing. Right? Is that clear?
Yeah.
Okay. So, this is not really hard. Playing with Qs and stacks is very straightforward. Get used to using your syntax correctly, guys. Okay? For stacks, we use push and pop. Okay? For Qs, we use NQ and DQ. Like any other professionals, you guys are going to become IT professionals, most of you, maybe some of you are gonna be computer scientists, but in any case, both of you have to handle your jargon correctly, okay? Just like doctors have their own slang that they understand between them, professional slang, lawyers do, we also have our own slang, our own terms, technical terms. And you can talk to your father, say your mother is not a computer scientist, you can talk to her and tell her, yeah, I have a Q, I'm gonna push some elements. And she will not detect the error, right? That's okay. But then if you go to a meeting where you are interacting with people, colleagues of you, and you say something like that, that looks very bad. It's very bad. And people can see how professional or how strong you really are in your field by speaking like that. Right? It's like you go to an attorney and if the attorney speaks professionally, you have more confidence than if the lawyer speaks like any guy on the street. Right? You understand what I'm saying? So that's the same thing, guys. When you go to a job interview and you start speaking, they will analyze that to see how professional, how strong you are. Okay? I don't know if I should share a story with you guys because otherwise it might take longer. But anyway, just keep your language good because otherwise somebody might come and make you look bad in front of everybody. Okay? That's what I did once. I can tell you, I'll tell you quick. I worked for a place. One of the guys that was the architect, he didn't have college education. He learned everything on his own, and he got to that position